mycotoxins are a serious threat to animal health. These invisible toxic compounds can impact gut health and immunity, leading to a diverse range of harmful and costly symptoms. There are more than 500 known mycotoxins, each one exhibiting different types of toxicity. Molds and feedstuffs naturally produce mycotoxins, and most molds produce more than one. Climate change and agricultural and feed storage practices are influencing the range of molds occurring in farm feed stocks. Alltech has conducted advanced research into glycomics and mycotoxin detection for more than 3 decades, leading to an evolution in our understanding and the development of unique solutions for inclusion in feed. The foundation of Alltech's mycotoxin management technology is the yeast Saccharomyces cerevisiae. This unique strain is grown under optimal conditions. Careful control of the fermentation process and carbon source allow the formation of a yeast cell wall that contains the ideal composition of carbohydrates. This yeast can be processed using a proprietary technique to expose this active component. With the right carbohydrate organization on the surface of the yeast, it can be enhanced with alternative carbohydrate compositions from a select strain of algae and can then go to work. We know that mycotoxins are initially bound to feedstuffs. It is only during the digestion process inside the animal that they are released and free to cause harm. The carbohydrate components of yeast and algae cell walls bind to mycotoxins, removing them from the animal's digestive tract. The fibrous and flexible mesh-like surface of the yeast cell wall components begin to adsorb these free-form mycotoxins. The surface flexes, and more sites open up, resulting in a rapid acceleration of the adsorption of mycotoxins. A closer look at the complex structural properties of the yeast cell wall reveals the key to success. Each strand of fiber on the surface of the yeast cell wall is made up of 4 triple helix strands, and each of these strands in turn is comprised of 3 single helix structures known as beta-D-glucans. Different shape spaces in the beta-D-glucans match perfectly with the shapes of specific mycotoxins, offering ideal sites for binding to take place. The flexibility of this structure allows it to adsorb a broad spectrum of mycotoxins in a single pass. And the unique algal component is able to adsorb some more of the same mycotoxins, but also some mycotoxin types that the yeast component cannot. The net result is an unparalleled capacity and speed of binding of a wide range of mycotoxins. Importantly, the yeast and algae components do not interact with the essential nutrients in the diet. Minerals, vitamins, and therapeutics, such as antibiotics, are left unbound, leaving these beneficial components free for uptake by the intestinal tissue, so they can perform their intended function. As the yeast and algae components calmly pass all the way through the digestive system, carrying away their dangerous cargo, farmers and producers can be safe in the knowledge that their animals' health and their own livelihood are being protected.